Good day. It is Ishola Michael once again, and it is Success Enlightenment. So we're going to continue our discussion on rules of differentiation. We've already observed the first five rules of differentiation. Now we'll be looking at the other five rules of differentiation. Here we'll be discussing the function of a function rule of differentiation, the logarithmic function rule of differentiation, the exponential function rule of differentiation, the parametric function rule of differentiation, and the implicit function rule. We are going to start our discussion with function or a function rule of differentiation. This function or a function rule of differentiation states that if y is a function of u, such as u is a function of x. So in this case, our dy, the x, will then be the what? Derivative of y with respect to u multiplied by the derivative of u with respect to x. This is what the function of a function rule states, except that if y is a function of u, and at the same time this u itself is a function of x, then the derivative of dy dx, because we want to find the derivative of y with respect to x, so our dy dx will then be dy du times du dx. This is the function of a function rule. It is also called chain rule. It's also called chain rules of differentiation. But what we are looking here is that we are given a certain function of y. And this y is expressed in terms of what? A function of u, that is a function of u, whereby u in itself is also the function of x. Let's illustrate this and we get what we are saying. For instance, let's say we are given the function such as y equals to 3s squared plus 1 all raised to power 4. Let's say we are given something like this. In this situation, this is a function of a function. Why? Because we can let 3s squared plus 1 equals to u. Now we can say y equals to u raised to power 4. In this case, our y is a function of u. That is, we can find dy du, which will be what? 4u raised to power 3. And at the same time, we can find what? Du ds, which will be what? Derivative of 3s squared plus 1 dx, which will be 6x. So in this case, our dy ds will then be dy du times du dx, using the chain rule of function, the function rule of differentiation, and this will then be equals to 4u raised to power 3 into 6x. Recall, your u is 3s squared plus 1, so you substitute that here. This will be 4 into 3s squared plus 1 raised to power 3 times 6x. 4 times 6, that's 24. Then this will be 24x into 3s squared plus 1 raised to power 3. And this will be the derivative of 3s squared plus 1 raised to power 4. Because this is a function of a function, and you have to use this chain rule in solving anywhere you see function of a function. It's very, very simple. All rules of differentiation, they are very simple, straightforward. They are very simple, straightforward. If you have to solve this using the first principle, definitely you will get the same answer, only that it will take you more time, to be more time consuming. So it's always very, very more easier to just use the rules of differentiation to differentiate as it saves time. The next rule of differentiation we'll be talking about is the implicit function rules. Implicit function rules. Now, the first thing we need to do to understand the implicit function rule is that we have to know the difference between implicit and explicit functions. Now, if you have a function such as y equals to 3s squared plus 2s plus 1, this is an explicit function because it clearly shows that y is the what? Dependent variable. That is, it is clear here that y is a function of x. But we have a function such as 3sy plus 2x minus 1 equals to 0. Here is an what? Is an implicit function because here it is not clear if y is the dependent variable or if s is the dependent variable. For you to make any of these dependent or independent variable, you have to at first make one of them subject of the formula. So this is what we call an implicit function. Now, how do we differentiate this implicit function? We already know how we can differentiate explicit function. We already mastered that. Now, in case of implicit function, how do we differentiate them? Now, let's take an example. It's very simple and easy. Let's take an example and we get it from there. Now, for instance, let's say we are given something like this: sy to 0. Let's say this is what we are given. Definitely, this is a what? Implicit function, because you cannot express this function y is a function of x. So, how do you differentiate this? Now, to differentiate this function, all we do is what? We differentiate each terms of this function individually with respect to s and with respect to y. Now, let's deal with the first term. The first term here, we have what? If you differentiate this with respect to y, so we have what? X dy dx. Because derivative y, this is respect to y, this we talk to 1, so we have x. So we differentiate the same term also with respect to s. What we have is what? Plus, this will be with respect to a, we have y dx dx. Now also this next term, we need to find the derivative also with respect to s and with respect to y. So this is plus, we find the derivative of this with respect to y. We have, now since there is no y there, so which means this s is a what? Is a constant. So we are going to have this what? Is 0 dy dx plus, when we find the derivative of this with respect to x, what we have is what? Is 1 dx dx. Are we getting it? Very simple. Just have to find the derivative of each of the time separately with respect to x and with respect to y. So now when we get to here, the same thing here we have minus. Now find the derivative of this with respect to x. So with respect to s is not here, so therefore it will be what? 0. Everything here is a constant, so it will be 0 dx dx. Now find the derivative of this with respect to y. This will be what? 3 dy dx. Same thing here. So find the derivative of this with respect to s. We have minus into what? 0 ds ds plus 0 dy dx. Everything equals to 0. So just find the derivative each of these times separately with respect to s and separately with respect to y. That is how you find the derivative of implicit function. Are we done here? No, we are not done. What's the next step? Now let's work with this. This definitely will give us what? X dy dx. This will be ds will be 1, so this will be dy ds plus y. This will give us 0. This will give us 1 plus 1. This gives us 0, this equals what? Minus 3 dy dx. This will give us 0, this gives us 0, so it is not needed, so equals to 0. Now from here, what we do is what? We collect the like terms. That is, we have x dy dx minus 3 dy dx plus y plus 1 equals to 0. Now we can take this to this side as we plan on making dy dx subject of the formula. From here now, this will be what? S minus 3 dy dx. That's if you factor dy dx out from here, equals to minus y minus 1. When this move to this other side, it changes sign. So what we have here is what? Our dy dx equals to what? Minus y minus 1 all over s minus 3. Now this is equals to, you can factorize the minus sign here. We have minus 1 into what? Y plus 1 all over s minus 3. Now this can be also solved further to be what? To be y plus 1 all over 3 minus x. So this is what? Derivative of this implicit function sy plus x minus 3y minus 3 equals to 0. What we have done simply is what? Is to find the derivative of each of the terms independently. So that is, you find the derivative of each of the terms separately. That's how you find the derivative of an implicit function. It's as simple as that. We'll be looking at so many examples later on, so we get it more, but this is just how it is. Find the derivative of this term separately with respect to what? Y. Here with respect to s. Come here, this with respect to y. This again with respect to s. Come here, this is respect to s. This again with respect to y. Come here, this with respect to s. This again with respect to y. Whatever you get, solve for dy dx by collecting the like times. That's how you find the derivative of an implicit function. The next rule of derivative we'll be looking at is the parametric function rule. This is also very, very simple. Suppose you are given that x is a function of p, and at the same time you are given that y is also a what? Is a function of what? P. X is also a function of p, so this is a parametric function. So in this case, how you find the derivative is what? Now your dy dx in this case is to find the product of these two functions and divide them by one another. What are we saying there? Now your dy dp here with respect to p, you find the y with respect to p, then y, and you divide it by what? Derivative of s with respect to p, which now equals to what? Dy, that is derivative of y with respect to p multiplied by dp with respect to s, and this will be equals to what? Dy dx. This is as simple as that. What this is saying is that we are given that x is a function of p and y is a function of p. Your dy dx will then be what? What is your what? Your dy dp divided by what is your ds dp. That's parametric function rule. Let's take one question to illustrate this. Now, given these two functions here, now the first function is we have x is a function of q and y is a function of q. That is, x is a function of q such that this equals to alpha q raised to power 3, and y is a function of q such as 3 alpha q. Now, to find the y ds, so you have to first find what is your what? Dy dq. So your dy dq here the derivative of this with respect to q, which equals to what? 3 alpha. When you apply the power function rule, equals to 3 alpha. Also, you find your what? Your derivative of s with respect to q, which is your ds dq, which is derivative of alpha square raised power 3, alpha q raised power 3 dq. And this will be equals to what? 3 alpha q square when you apply your power function rule. Now recall, what you are looking for is the dy ds, and we said that dy dx equals to what? Dy dq divided by ds dq, which is then equals to what? Dy dq times dq dx, which in this case, what is our dy dq? Our dy dq is what? Is 3 alpha. And what is our ds dq? Our ds dq is what? Is what? 3 alpha q square. It's 3 alpha q square. So therefore, dy dx here will be equals to what? 1 over q square. And this is a what? This is the derivative of this parametric function. It's very simple. When you're asking to find the derivative of a parametric function, all you just have to look for is that what? You're having x expressed as a function of q, and you're having y also expressed as a function of q. That is, x is expressed as a function of a variable, and y is also expressed as a function of that same variable. So what you do there is you find derivative of y with respect to that variable, and you find derivative of s with respect to that variable. Y, you divide the derivative of s with respect to that variable by the derivative of y with respect to that variable. So, and that's how you find your dy ds. Now, the exponential function rule is also very simple. When talking about exponential function rule, what we are really considering here firstly is what? A derivative of given the function as y equals to e raised power x. Yes, this is what we are looking for here. And when you given this by exponential function rule, the dy ds2 is equals to what? E raised power x. Equals to e raised power x. And what we need to note here specifically is that the derivative of exponent is also the repeat of itself. But in most cases, this works with what? Chain rules. Because when you look at this very clearly, this is a function of a function. This is a function of a function. Now, in most cases, when you have exponential function rule, you are to apply chains rule. To make it easy, let's illustrate. Let's say we have y equals to a. Let's say this is what we are given, y equals to e a raised power x. Say this is what we are given, y equals to e a raised power x. So the first step is what? Let a raised power s equals to u. So therefore, y equals to e raised power u. So from this, our dy dx using chain rule will now be equals to what? Derivative of what? Dy du times derivative of what? Du dx. So from here, derivative of dy du, which is derivative of e raised power u with respect to u, will equals to what? E raised power u, according to our exponential function rule. Why the derivative of what? Du dx equals to what? Derivative of what? A raised power x dx, and this will give us what? A. So now when we simply have to do is what? Find our dy ds, which is the product of this, so which is then equals to what? A e raised power u. Don't forget, your u is what? Equals to as, so you substitute that for u here. So which then makes this equals to what? A raised power E raised power A E raised power A S, which equals to A E raised power A S. So that is how exponential function rule is done. Mostly when you see exponential function rule, you are mostly applying function of a function in most cases. So what you simply do is what is raised to power, you just make that u. Even in this case, let u equals to what? X. So simple, what you have is what? Y equals to e raised power u. So your d y du will be e raised power u, while your du dx equals to what? 1. So here you have 1 times e raised power u, the same thing as 1 times, the same thing as what? E raised power x. So that's how exponential function rule works. It's logarithmic function rule, derivative of logarithmic function. Now, for instance, let's say we are given a function such as y equals to log s base e. So how do we solve this? And the first thing we do here is we transform this to what? Exponential function, such as we have e raised power y equals to x. At this case, we can find about what? The x, the y, using our knowledge of exponential function, which our ds dy here will be what? Derivative of e raised power y with respect to y, which is empty as what? E raised power y. Because we are looking to find our what? The y, the x. That's what we are looking forward to finding. We are looking forward to finding our dy, the s. And in this case, our dy ds, our dy dx will be a reciprocal of this, which is what? 1 over e raised power y. But recall from here, we already noted that e raised power y is equals to x. So therefore, substituting e raised power y, s for e raised power y, yes, we have what? Dy dx is equals to 1 over x. So from here, the derivative of logarithmic function is simply as what? 1 over the what? The number that the log is being taken into. This is the natural log limit. This is a natural log limit. Suppose logarithm, we have logarithm could be this. Let it logarithm to base e is a natural log, and derivative of logarithm to base e will give us what? 1 over the number you put to that natural log. That's what the logarithmic function rule is saying. But should in case you are given a log that is not in, let's say you are given common logarithm, that is logarithm in base 10 or logarithm to any other base. Now the first procedure you are going to do is what? Is to at first change the base of that log to natural log. Once you change it to natural log, then you what? You find the derivative of that. And it's very, very simple. You can easily change the base of any log to natural log. Suppose you are given, for instance, you are given log x base b. I want to change it to natural log. So you can simply do this by just finding log s base e all over log b base e. So you successfully change this to natural log using this formula. It's as simple as that. And suppose we are given something like this, log e base b. So to simply change this to natural log is just apply our knowledge of logarithm. This is as what? 1 minus what? Log b base e. So that's how you change logarithm from any log to what? To another base. For any base to another base. But in this case, we are interested in what? In natural log. So let's take one example. Suppose we have something like this. Y equals to log 5s base e. So what we do here is what? We can let u equals to what? 5x. This is a function of a function. So therefore our y equals to log u base e. So from here, the logarithm to the natural log of logarithm, that is the y, derivative of the y, the u here which is what? Log of derivative of log of u base e with respect to u will be what? 1 over u, from what you have already established. That from the logarithm function rule. And the u, the x here will be equals to what? 5, derivative of this. So therefore our dy dx will be equals to what? Dy du times what? Du dx, which same thing as what? 1 over u times 5, which is 5 over u. Recall our u is what? Is 5x, so which is then equals to what? Of 5 all over 5x, which same thing as what? 1 over x. This is just 1 over x. Another way you can solve this is y equals to log 5x base e. Then this can also be written using the addition and product law of logarithm to be y equals to log 5 times x base e equals to y equals to log 5 base e plus log s base e. From our law of logarithm function, definitely 5 is a constant, it's not a variable, so logarithm to any derivative of any constant is 0, this will be 0, so dy ds from here equals to 0 plus 1 over x, so dy dx here will be what? 1 over x, which is the same thing as what we have gotten from here. So that's logarithm function rule.